Hello there, welcome to my brand new YouTube channel. Since this is my very first video, I want to introduce myself in 25 seconds. My name is Krishna Acharya and I am an AWS Cloud Architect. I have been working in software development arena since last 15 years and in AWS Cloud since last few years. I beg your feedback and comment after watching this video, which will help me do better next time. I really appreciate your feedback. I would love to connect with you. Here are a few of my social media channels. Here I am going to go over the capabilities of AWS SAM and cover many of the major features of AWS SAM. It will be mostly hands-on lab where I will be creating brand new serverless application, build and deploy using AWS SAM, and you can follow along and do hands-on with me if you want. I'm going to put the instruction on what you need to do to set up a developer environment in the description section. Please check that out. So we'll cover the theory first. In the theory, we will cover SAM template, and SAM CLI, and we'll do the hands-on. There is no hard prerequisites for this lab, but if you have familiarity with AWS services such as CloudFormation, Lambda, API Gateway, Code Commit, S3, on the programming language side, Python and IDE, Visual Studio Code, in the subversion side, Git AWS commit, that will be great. That will help you. AWS SAM, which stands for Serverless Application Model. AWS SAM is an open source framework to develop production grade serverless application. And it is a IAC tool, infrastructure as code tool, to provision serverless application in the cloud. At the end of the day, it is a toolkit which improves developers' productivity to build and run serverless applications on the cloud. And AWS SAM has two parts. The first one is AWS SAM template, another is AWS SAM CLI. But I would like to take a step back and think why we need AWS SAM. If we did not have SAM, we would have to go to AWS console, click around, and provision the resources and deploy the application manually, which is fine. In one account, that is fine, and it is easy also. But what if you have many accounts, maybe hundreds of accounts, and you want to deploy the application in those accounts? It's not very easy, right? It takes a lot of time. There is no automated way. So that's where AWS SAM comes in very handy. It has shorthand notations, which will help you to provision the infrastructure and deploy your applications in the cloud, which we are going to see in the next slides. AWS SAM template is an open source framework, which is basically a YAML file where we can define and manage serverless application infrastructure. AWS SAM is an extension of AWS CloudFormation. If you already know CloudFormation, syntax should look very similar, but it offers its own unique syntaxes that focuses specifically on speeding up serverless development. AWS CloudFormation and AWS SAM syntax can be used together within the same file. And we still use AWS CloudFormation service to process SAM template. Let's look at an example of AWS SAM template. In this example, we are defining the version on the top, which is going to be same across all the templates we will be writing. The second line, which is a transform, which tells CloudFormation service that this template is not a CloudFormation, this is a SAM template. Under resources, we will be defining all the resources that we want to create. Here we are creating a Lambda function. The type AWS serverless function means basically a Lambda function. Under properties, we are defining the properties. Under handler, we define the code. Runtime, we will define the runtime environment for the code. Under events, we define the events that will trigger the Lambda function. In this case, we are creating a API of type HTTP API with path slash and method of get. Under connectors, we're going to create DynamoDB table. The last line, type AWS serverless simple table, is basically a DynamoDB table. What happens if we feed this SAM syntax through CloudFormation service and execute? It will create this infrastructure. In this infrastructure, you can see API gateway, Lambda function, and DynamoDB. User makes a request to HTTP API endpoint, which invokes Lambda function, and Lambda function in turn invokes the DynamoDB table. And this implicitly creates an IAM rule for us. Here we have 23 lines of SAM code. And if we have to create the same infrastructure using CloudFormation, it's going to be 200 lines of code. Now you can see how efficient SAM template would be, right? SAM CLI is an open source CLI tool to develop serverless application. It helps to quickly initialize a new application project, build the application, perform local debugging and testing, deploy the application, monitor and troubleshoot application in the cloud, sync local changes to the cloud as you develop, and more. Let's take a step back. Why do we need SAM CLI? We already have a SAM template, right? If we don't have a SAM CLI, it's just a standalone. We cannot do anything with just a template. It's a file. SAM CLI is a tool that will take that file and it builds and deploys the application from that template. That's why we need SAM CLI. Hands-on time. If you want to follow along with me, consult the description section of this video where I have put together all the instructions to set up your developer environment. And here are some prerequisites. You need to install AWS CLI, install SAM CLI, Docker for local testing, VS Code for IDE, create AWS account, and create one AWS user with access key and secret access key, which gives you programmatic access. Install git-remote-codecommit, configure the user credential and account. The first command you use is SAM-init. SAM-init is a SAM CLI tool that scaffolds a brand new project and gives a solid foundation from where we can start developing our application and add features. Let's run the command and we'll see the folder structure and review some important files that got generated automatically for us. So I'm in my home directory and underneath cloud dev, I'm going to create my own folder. AWS SAM training. And I'm going to Visual Studio Code and open that folder. SAM app, SAM, AWS SAM training. Open. Okay, we opened that folder in VS Code, but there is nothing. Let me open the terminal also. Okay. So we are under Cloud Dev AWS SAM training, which we just created. Okay. Here I'm going to run SAM init. And it gives you two options. Either you can create a brand new project, or if you already have a template, you can use that template here to start with. So in our case, I'm going to give number one to create a brand new project. And AWS SAM also allows you to create different kind of serverless applications. In this lab, we are going to create a hello world. Use the most popular runtime and package type, Python and zip. I'm happy with that. So yes. Would you like to enable X-ray tracing? No, for simplicity. Would you like to enable monitoring? No, for simplicity. And the project name, you can give SAM app demo. All right, it already created a brand new project for us, which we can see on the left-hand side. SAM app demo. that we just created. Underneath SAM app demo, it created multiple folders and files underneath. So here, the first we're going to look at hello world folder and app.py. This is the core or brain of the serverless application where we write our application code. We write our code under Lambda handler method, but the name can be anything. It does not have to be Lambda handler. Lambda handler takes two arguments, event and context. Event contains information about the invoker. Context argument contains information about the invocation, function, or runtime. For example, we can give information about CloudWatch log stream name, remaining execution time of the current function execution, and this function returns status code along with hello world message, which you can see here. The requirement.txt is another file. This is where we define the dependencies that our Lambda function requires. samconfig.toml file. This is a configuration file that stores default parameters used by AWS SAM CLI. Template.yaml file. This is a SAM template that we talked about earlier that contains IAC code to provision the serverless application. If you are familiar with CloudFormation already, you might think that it's exactly like CloudFormation template. Yes, that's because SAM template is the extension of CloudFormation template. And we can even mix SAM syntax with pure CloudFormation syntax in the same template file. And SAM uses CloudFormation service to process the template. Notice the first line, it defines the version. And the second line, the transform line, which tells CloudFormation service that, hey, this is not CloudFormation template, this is a SAM template. The global section contains the parameters values that will be shared across all the Lambda functions and APIs. In this example, we are defining the timeout value of 3 seconds and memory size of 128 megabyte. Under the resources section, we define the resources to be created. This template creates a Lambda function and an API gateway that exposes a hello/hello resource as shown in the diagram, which I'm showing in this diagram here. An IAM role is created automatically, even though we don't specify explicitly. This Lambda function requires the role here. When called with the HTTP GET request, the API gateway invokes the function which assumes the IAM role with permission to interact with other AWS services such as database. For simplicity, we have not added database or any other services that Lambda could interact with. The last section is the output section, but this is a optional section, but we can define output values that we can use in another CloudFormation template or to simply view the output from the AWS CloudFormation console. So it also created the events folder. It has events.json file. This is basically the events that we can use in our application. And the other important file is the tests, where you can write integration testing code and unit testing code. Next command we're going to run is SAM build. It builds the project and creates artifacts for the deployment. Let's go ahead and run SAM build from the terminal. SAM build. Got an error. Template file not found at that location. Okay, I know what it is. We need to be under SAM app demo folder because that template file is located underneath SAM app demo cd. Now we're going to run SAM build. It's running. All right, it ran successfully. If you look at on the left side, this is the new folder created by AWS, that SAM build command. Okay, Let's check the important files that got generated. Hello world function under build. It contains the Lambda function, which is this app.py, and all others are the dependencies. AWS CLI creates folder for each Lambda function. This is the folder created by AWS CLI. In this case, we have only one Lambda function. That's why you are seeing only one Lambda, this folder. If you have multiple Lambda function, and you will see multiple folders like this here. Template.yaml file. This is a copy of our AWS SAM template that AWS CloudFormation uses at the time of deployment. Build.toml file. It contains the default parameter values referenced by the AWS SAM CLI. Next command is SAM deploy. SAM deploy, as the name suggests, deploys the application by deploying the artifacts that we created in the previous step. Now let's look at our Visual Studio Code terminal to see this in action. So before deploying this application, we need to configure the environment. We do AWS configure and provide the AWS access key and secret access key. For that, you need to create AWS account first and create a user with a programmatic access. I'm not going to show that here, but if you need help, let me know. I'm also going to provide the instruction on how to do that in the description section. So I'm going to quit this with a Control C. Let's clear the screen. SAM deploy guided, which is the command I need to run. Run deploy SAM deploy guided. Okay, it's asking the stack name. I'm going to hit enter. It will take that name, SAM app demo. This stack name is going to be the CloudFormation name. Just remember that. We'll see that later. And AWS region, I'm going to use US East 1, hit enter. Confirm changes before deploy. Yes, I would like confirmation. Allow SAM CLI IAM role creation. Sure. Disable rollback. No, I would want to be able to roll back if something bad happens. Okay, here is a very good catch. Hello world function has no authentication. Is this okay? We're going to say okay, but this is a nice catch because real world in the real world scenario in the production grade system, we need some kind of authentication. So yes, save configuration file. Yes, SAM configuration. Yes, SAM configuration environment as default. Now it's going to take a minute. It's doing something here. But in the meantime, I'm going to the AWS console and look at the stack here. Is it creating something? Okay, yeah. So this first stack, AWS SAM CLI managed default, it's creating something here. If you go to the events tab, it shows what's going on. We'll go back here and say, okay, this is still doing something. Okay, SAM CLI source bucket. The first CloudFormation template created the source bucket. And it created the bucket policy also. Okay, I think it's complete. We can go back and see. Okay, this is complete. Create complete, right? The next stack is SAM app demo. If you remember, we gave that name in our previous screen. Let's see what's going on the Visual Studio side. Okay, it's asking, okay, deploy these changes. Yes. Now it's going to take a little bit of time here while it is cooking here. We can go and check what's going on underneath app, the SAM app demo. events. So it started with creating some app demo. It's creating different resources. I'll go and check create complete, which is basically the same thing here. We can see the status. Give a minute and also go and check here. All right, looks like this is complete. If you go to the resources section, it gives all the information about the resources created here, and output section shows the output. Okay. All right, it's done here. Successfully created, updated this tag. Now let's go and quickly validate resources if they were created successfully or not. We'll check a Lambda function here. We'll open in the new tab and see if this is really there or not. Yes, it is there. Under code, we'll see if there are some code. All right, we have code here. Okay. Similarly, we can check the API gateway. Here's a REST API. I click on this link, physical ID, open in a new tab. And click on, okay, you can click on stages and you can choose prod, hello, and get this link. And we can quickly test if this is working or not, if it deployed successfully or not. Hit enter. You have to pass the path hello for that API gateway. Now, see, you get the response, hello world, which is coming from the Lambda. Okay, so we can look at some of the other resources created here. S3 bucket. Let's go and see S3 bucket. With the first CloudFormation template, creates this S3 bucket, which contains SAM app demo folder with the template. And when we deploy, it takes this template and deploys. The first step is to deploy or upload the template file into S3 bucket. And the second step is to get the data from here and deploy. That pretty much covers this one. Let's do some testing here. It's going to be fun. We will do testing in the cloud first, then we'll do some testing in your local machine. Before doing any testing in the cloud, we need to run SAM sync watch, which we are going to see here. In Visual Studio Code, I'm going to run the command SAM sync watch. This command will sync your local changes to the remote code, which was deployed earlier. Okay, it finished syncing. So what happens here is as you make code changes, it's going to deploy instantly in the AWS account and you can view instantly. Let's see. So this is the existing code. I deployed this hello world, blah, blah, error. Now I'm going to correct that. And I'm going to just change it and I hit the save button. I'm going to, yes, I hit the save button. It's running. Finish syncing. Now I'll go here, hit enter. See, it changed it. So this is really, really cool. You don't have to go through the CloudFormation to redeploy if you make changes, which is going to save you a lot of time. What AWS CLI does is it calls the service API directly and deploys your code. If you don't want this to run, do Control C. It will stop syncing and you can make code changes and it will not deploy. This command, sam sync watch, will look at all the files. But if you just want your Lambda code to be synced, what you can do is you can pass dash dash code and it just looks at your all the Lambda functions. Or you can be very picky about, okay, I would like AWS Sync to look at only this file, then you can just pass resource ID, which covers the testing in the cloud. Now we are going to do testing locally. So in the local testing, the prerequisite is you need to have Docker installed and running. The first command I'm going to run is sam local invoke. Going to Visual Studio Code, sam local invoke. This is going to invoke that Lambda function. In this case, we have only one Lambda function, so by default, it invokes that Lambda function. If you have multiple, you can pass Lambda function as a parameter. It's running. It's invoking the Lambda function. All right, it invoked, and it gave this message hello world, which is good. It verified that our application is running locally fine. Another way to test this out is AWS, okay, sam local start lambda. Sam local start lambda. This also tests the same lambda function. You will see the difference. Okay, so what this command does is it deploys the lambda function locally in the container and gives you the URL. See, that lambda function is running in HTTP 127.0.0.0.1:30.001. Now we can use that endpoint to test our lambda function. I have a command here which I'm going to copy and open another terminal. And I'm going to, hit enter. All right, it gave us a status scope of 200 and we passed this out.txt file here, which got generated, and we can see hello world message here. So yeah, this is those are two ways to test the lambda functions. You can go to the slide here and see the difference. Sam local invoke versus sam local start lambda. Sam local invoke directly runs your lambda function, and you can see the result right there. But as you saw, sam local start lambda runs your lambda function in a Docker container and gives you an URL, which you can use to invoke that one, which may be very helpful in testing. The next one we're going to do is sam local start API. I'm going here, I'm going to click Control C. Now that lambda function is not running. And I'm going to run the another command, sam local start API. Sam local start API. Okay, template file not found. Okay, I need to go to cd demo sam local start API. Okay, and it's working. Okay, I think it is working fine here. And it's giving this URL. And this API is running on this link. Which can copy and paste here. We need to pass hello. Yep, now you can verify that locally also. With that, we have concluded our lab for today. So to recap, in the beginning, we scaffolded a brand new project using SAM init. Then we built the project using SAM build, and we deployed the project using the command SAM deployed dash dash guided. And just now, we tested in the cloud and locally as well. Before you go, clean up the resource. There are two ways to clean up. First, using the console, and second, you can also use AWS CLI tool. I'll show you how to delete the resource from the console. Go to your CloudFormation. Then you will see your stack name. Click on the stack name and click the delete button and hit delete. I'm going to show you how you can do the same using CLI. Go to your Visual Studio Code and execute this command: AWS CloudFormation delete stack dash dash stack name and your stack name. Hit enter. It says an error occurred when calling delete stack. One validation error detected. Some app tutorial add stack name field to satisfy concern. Member must satisfy regular expression pattern. Let me see. All right. Now let's go and check. Now it says delete in progress. We just started the delete process. Similarly, you can delete the another stack as well. So there are a couple of best practices you can follow. You need to run SAM build command every time you make code changes. Otherwise, you will risk running the old code inside .aws SAM folder. Every time you build a project, it updates .aws SAM folder. Otherwise, your local testing will have old code. Test the code locally as much as possible, first using SAM local and then in the cloud with this command, AWS sync dash dash watch for integration or broader testing. Don't use AWS sync dash dash watch in a production environment. You know why? Because you might be running your bad code in the production environment. So only do this in dev environment. Let's recap what we have done. We talked about the prerequisites and we configured our AWS environment and we ran those following commands: SAM init, SAM builds, and deploy to initialize the project, build the project, and deploy. We also did local testing using those commands. And we also used SAM sync command. And finally, we cleaned up the resource using this command. Thank you for watching my video. I hope you learned something about SAM today. If you have any question or get stuck in the lab, please let me know. I will definitely help you out. Also, please consider subscribing my channel if you like this video. I will be bringing exciting topics on AWS next time. Until then, goodbye.